There's a reason they call it rocket science. Since the 1950s, the nation has pursued a test-driven development or bust-build-bust approach to developing liquid rocket engines based on empirical data and rules of thumb. This involved thousands of tests on liquid rocket engine components and full-scale engines over the last 50 years. In 2002, at the request of Air Force Space Command, the Air Force Research Lab, AFRL, set out to develop physics-based modeling, simulation, and analysis tools. This enables model-driven development for liquid rocket engines, replacing the current empirical tools that are over 30 years old. This approach will literally save billions of dollars in development cost. The upper stage engine technology, Uset program, is changing how we design, build, and test liquid rocket engines in the nation. AFRL brought together a diverse team of industry, academia, and government experts to work the problem. They identified models, the physics that's needed to be understood, and developed a plan to capture this information in new tools. The tools were used to design a high-performance and highly instrumented turbopump, which was tested at AFRL's Test Stand 2A at Edwards Air Force Base, California. Using a single set of engine hardware, vice the dozens typically used on past programs, AFRL conducted 30 tests validating the accuracy of the models, a critical step to industry acceptance and use, as well as significant development cost savings. The program was so successful that even before testing of the turbopump had begun, industry had already used the tools in 57 commercial and government applications. The tools are playing a critical part in AFRL's hydrocarbon boost demo, which is establishing the technology base in the U.S. for oxygen-rich stage combustion. This work enables the replacement of existing engines or engines for future launch vehicles. Space and Missile Systems Center has determined the tools are also critical for their effort to replace the 40-year-old RL-10 upper stage engine used on both the Delta IV and Atlas V, and has funded AFRL for additional risk reduction efforts. AFRL, dramatically changing the face of space access.